So, continuing our discussion, we were in the area of asset liability management. So, what are the building blocks? So, as we were discussing, the risk drivers still the capital. So, risk drivers are the main risk variables, parameters which the bank is facing, which the financial institution facing, such that the overall risk exposure increases. So, you have to find out whether it is foreign currency, whether it is interest rate, whether it is oil price, whether it is gold price, and all these things. Then you will also consider what is the risk exposure. Risk variables would be there, but you have been exposed to that. So, obviously, that would be a overall risk exposure. Say for example, if I am a bank, I know the change of the dollar to yen value really affects my overall risk exposure, but if my overall risk concept and if I have not invested in any dollar denominated assets or all any dollar denominated liabilities or not into yen. So, obviously, those risk exposures would not come. So, any change in the dollar and yen would affect those dollars and yens asset and liability, not the other one. So, if I have only dollars and only assets and assets in yens, so obviously risk exposure is the highest. So, you might try to understand what are the parameters which are affect and what are the actual exposure you are trying to face. So, you will try to basically make a one-to-one correspondence and then try to analyze your overall risk. You also find out the standalone risk, valuation and adverse deviations of interest margins if you considered IM and the concept of interest rates, how they affect your standalone on a one-to-one basis. Then if standalone basis risk is found, obviously there would be a correlation between them because they are random variables. So, if you consider, then you have to find out the correlation, which is the covariance variance matrix is the ultimate goal. Now, as I mentioned, finding out the correlation coefficient of the covariance matrix becomes difficult because data is not available. So, there you have to be careful how you find out the correlation coefficient or whether you are able to find out some proxy to find out that covariance variance matrix. Given this correlations, given this risk exposure, given the risk drivers, you find out the overall portfolio risk. So, you want to basically find out the portfolio risk, balance it with the return and then basically make a decision whether that investment is really worthwhile, considering your main aim is, again I am mentioning, is to minimize the risk. And you want to find out what is the capital. So, in general we are interested in matching the assets and the liabilities so as to maintain a permissible level of gap, because gap is also dependent on time, if you remember marginal gaps and all these things. So, if you bring into the picture the overall capital, which is basically a concept of gap, how it is being managed within a permissible region is also a building block for the ALM. So, for the asset liability management, we analyze the borrower, the facility and the final price. Under the borrowers, you have to do different type of qualitative studies which analyze the application for the loan, characteristics of the applicant, what are the industry characteristics, what is the economic characteristics, what is the financial statement, profit and loss, balance sheet of that company, what is the business plan, who are the main person who is running the company, what is the present economic scenario which I have already discussed, what is the present and the future economic scenario, how the country is doing, how the market is doing, what is the market share, and all these things are considered. Facilities is that when you facilitate, you find out the pricing base, whether it is a LIBOR one, whether it is the MIBOR one, whether it is a LIBID one, MIBID one, whether it is a fixed rate. You find out the time duration of the loan, is it long term, short term, you find out what are the collaterals, you find out what are the guarantees, you find out the matching funding cost have been made. So, if they are taking a loan, obviously collateral is important, but whether they are trying to match that overall loan with their own amount, that means the company which is trying to borrow, such that in case of risk they would also face the risk and they are in a much better position in order to tackle the risk. What are the other overage, what are the other fees, so whether they are competition from other lenders. So, if a bank has another competitor as a bank, so obviously you have to tackle it very delicately, because if the interest rate, if the overall benefits being given by the other bank is on the positive side for the other company which is taking the loan, obviously you as a banker will face a loss of business. And then based on all these things you find out the final price. So, this is for the asset liability management, I am just giving you a simple matrix, transition matrix, but note down the word transition. It means that in the first row you have basically ABC, which are the different type of assets or portfolios, and similarly in the first column. So, if you find out the matrix values, it basically gives you that given one is in A, the probability of shifting from A to A is 90%. Then again this means that given C, probability that will continue remaining in C is 0.93%. But if you see the off the diagonal elements, it gives you this, that if you are in B, then slowing down or going down to basically C is 0.06%. But remember one thing, see this value, they are different. So, if I am considering that I am at B, moving to C is 0.065, and in this case if I am at C, then moving up to B is 0.06. So, this diagonal which I draw are the probabilities of staying at the same level, and the off diagonal element are moving from I to J or J to I. And obviously, it would very simply and very logically mean that such movements are not of same probability. So, if you see the matrix, the off diagonal element, they are not symmetric, not symmetric, not symmetric, not symmetric. That means, moving from B to C or C to B, moving from A to B, B to A are not of the same probability. And this transition probability matrix given is for only one time. So, as you move from time 1 to time 2 to time 3, this transition probability matrix also changes. So, this is the gist. Given Aij, we know that probability J, given it was an I, is given by Aij. That is, given a company is at rating I, the probability that it will continue to go to a new rating J at the end of the stipulated time, that time factor is given by Aij. Point 1, remember, it is not symmetric, addition of the rows should add up to 1, because it is very simple to understand. If you are at A, you can either move to A, go to B or go to C, so there are no other positions. So, some of them should be 1. Similarly, some of them should be 1, because out of that position you can move, either stay at the same level or can move up and down. There are no other positions. So, obviously, the total probability is 1. If you are given A, the transition matrix for a year, then you can find out the investment or transition probability matrix for the second year, considering the correlation coefficient needs to be the same. So, what you do is that multiply AA. A is the transition probability matrix for 1 year, A square is the transition probability matrix for 2 years. Similarly, AN would be the transition probability matrix. Consider that you have started at 1 and you want to continue and find out what is the transition probability values after n years. So, this is a very simplistic assumption, you multiply A n number of times, find out AN, but the fact remains in practical sense that is not true, because what you are trying to do, a priori you are considering the one time period information is being transferred to the n minus 1 time periods at a constant level. Hence, the n transition probability matrix which you multiply is multiplication of n values. So, all these n values assumes the later n minus 1 are all dependent on the first one and they are constant, which is not true, because if you consider the transition probability matrix for second year, it is dependent on the first year, that is true, but other factors would also help change the values. Similarly, if you consider the transition probability matrix for third year, it is dependent on second year, it may also be dependent on first year, but there are other factors also. So, what we should be aware is that as the transition probability matrix changes from year 1 to year 2 or time period 1 to 2, how is the dependent structure known? We have to use that to find out the second year transition probability matrix. Given the second year transition probability matrix, you will find it for the third year and so on and so forth. But if data is not available, in a very simple case, you can assume AN, which is a multiplication of n number of times of the A matrix to find out the transition probability matrix for n number of years. Rather than extrapolating the information from the first to the nth year, we can proceed iteratively, as I was saying, such that you find out the second year, given the second year to find out the third year, given the third year you can find out the fourth year and so on and so forth. But again remember, in transition probability matrix, if you want to have that information to find out the standard deviation, then standard deviation is dependent on a function of square root of t, which is a very important fact to remember. One of the main reasons is how to incorporate the effect of the correlation between credit quality of the assets in the portfolio Assuming that the distribution of borrower risk is normal, we can characterize the relationship between the risk in two different borrowers using the correlation coefficient matrix or the values. Now, this is the graph which you see. So, if you have these as double A, these as single A, so what you want to find out to what is the transition probability happening from AA to A. Similarly, this is from A to B, B plus. Similarly, this is from BBB to triple C. So, if you have the transition values, the principal diagonal means the same state, off diagonal elements means from different states. So, this can be found out in the matrix formula for only one time period. So, what you will have is for different time period you have the distributions. If you have the different distributions, the underlying distribution properties may be different, but they are of the same class of distribution. So, if they are skewed, they will remain continue to be skewed, but the parameters, the location parameter, the scale parameter, on all these things values for the distribution will change, which will have an effect on what is the expected value, what is the variance of that particular distribution. So, if the distribution by itself changes, the matrix based on which you are trying to do your calculation would also change. So, what we meant in the initial slide was as A changes, hence finding out AN may not be right. By quantifying this risk, we are interested in capturing the main effect of the risk and the magnitude of the same in profitability, which is the main focus of the bank. Following the regulator's risk, a very important concept of risk comes into the market, which is known as value at risk. Briefly stated, value at risk is a potential loss due to a defined level of risk a company or a FI or a bank is facing. In other words, VaR measures the worst expected. So, this is very important for us to understand. I will just highlight it. So, I will use the highlighter. So, this is what is very important for us to understand. And as I go through the concepts, this will become clear to you. Let me first highlight. So, it means in other words, the VaR measures the worst expected loss under normal market condition over a specific time interval at a given confidence level. So, what are the keywords here? Keywords are worst expected loss under normal market condition over a specific time interval at a given specific level. So, that means time and level of confidence are very important parameters to define VaR. So, let us consider the statement and understand the risk. Suppose that a portfolio manager has a daily VaR, daily, this is important because time factor is coming into the picture. Daily VaR value of 5 crores at 2%, again this is important. This means that in only 2 chances, so 2% means out of the 100, 2 chances, in 100 number of days that a daily loss greater than 5 crores under non-normal market condition will occur. So, if I say that I keep that amount of 5 crores, it means and a 2% confidence level for a daily value, it means that if I continue doing that, taking the scenario, then out of such 100 number of days, there would be instances 2 number of times where my overall loss would be greater than 5 crores. Now, you may be thinking that why I am mentioning daily, cannot it be done weekly with the same definition? Answer is no, because if you remember, again I am repeating, we mentioned that the concept of risk is dependent on time. How? Standard deviation function of square root of t, variance function of t. So, as you increase the gap using day if you want to find out for 2 days, given day if you want to find out for 3 days, then the time factor would also be coming. So, hence the overall risk is not anymore the overall VaR, that is the VaR or the value of risk you are trying to keep is not no more 5 crores per day, it will basically change, it will not be twice, it will not be 10 crores, it will be much more because the time factor would also be coming into the picture. The value of VaR is a potential loss based on present value. Portfolio loss can theoretically extend to the value of entire portfolio. In other words, VaR is a maximum loss at a present confidence level. The VaR methodology serves us to define risk. So, this is just the simple background and the definition which I have given. So, now I will basically state it very simply using a graph. So, advantages of VaR are it provides a complete overview picture, captures the downside is very well, it is practically definitely feasible, but it is technically in the actual sense if you go into the nitty gritties it is not right. Remember is very simple. The concept of normality we have considered is the underlying fact assumption for VaR. So, if you are considering normality of distribution, which means we are considering utility functions to be quadratic, then all these things statement which I have made is true. But if the distribution is non normal, then VaR is used as a measure, but it would not give you the actual picture. And another advantage is that assigns a monetary value to the risk, hence it can be quantified and easily understood by people. It is simple. VaR is also called the expected value or risk which you are basically facing or earning at risk. Earning at risk shares the same underlying concept as the benefit has been relatively easy to measure. Although similar to VaR, the ER which is earning at risk does not relate the adverse deviations of the earnings to the underlying risk. Hence, R aggregates the effect of all risks, but contrary to that VaR requires the linking of the loss to every risk. So, there may be other losses also. What I want to find out is on an individual basis what is the in a portfolio the overall effect which is happening, and that would be given much better by value at risk. So, considering the concept of VaR, we will with a simple diagram consider the expected loss, a type of risk, unexpected loss and an exceptional loss, and that also will lead us to the concept of conditional value at risk, which we have not written, but I will discuss with a very simple diagram. You expected loss, it is the upper bound of the loss not exceeded in more than limited given a fraction of all the outcomes. This is a loss that we will face sooner or later. Therefore, it makes sense to deduct expected loss from all the revenue since it represents an overall average change. So, how it is done? Let us continue. Unexpected loss, which is VaR, as I had discussed, it is the overall risk which you are facing per day at a certain level of confidence. For example, if we say it means 100 means that if it is given as 100, it means the loss exceeding the value of 100 is no more than 1% of the cases, because the confidence level is 1, which means that out of the 100 such cases, one case would be where the loss would exceed that value. An exceptional loss is the loss which is excess of the sum of the EL plus the unexpected loss, which is VaR. So, only stress conditions can under stress conditions can we think how to calculate the exceptional loss. So, now with this diagram let us consider EL is the expected loss which you already have to click, UL is the unexpected loss from where you will get the concept of VaR, and this is the exceptional loss which is over and the VaR. So, now if you remember I did mention what is C-VaR, which is conditional value at risk. So, conditional value at risk is very simple. If you have the value of VaR here, say for example VaR here, what you want to find out is what is the overall area of the right hand side and what is the center of gravity of that. So, what you want to find out is that you find out the overall distribution on the right hand side of VaR, considering that losses are increasing on the right hand side, and find out the center of gravity of the expected value. So, this is the C-VaR which you want to have, and C-VaR and VaR at one go would give you a lot of information if your distribution is actually normal. But if I am talking about the non-normal distribution, I did mention VaR would not be right, but still it can be proved mathematically that C-VaR would give you much better result, because it has some very nice properties under symmetric and asymmetric distribution which is not held by VaR. VaR has only this properties under symmetric distribution, and while under asymmetric distribution it does not follow those properties, while C-VaR has those properties. So, again coming to VaR, if we mention by x as the value of VaR, so it means the V value as VaR, so and with certain percentage and certain this number of days, we are, so when we state we are x percentage certain that we will not lose more than V amount of money in the next n days. So, this value of V is the VaR, this is the number of days based on which you are trying to find the VaR, and this is the percentage of confidence level. So, again coming back to the same thing which I am repeating, sorry for that. So, if you have the yearly one and if the daily one is given, you will basically multiply by the square root of 365. If you have the weekly one, multiply by square root of 52, you find out the yearly one. If it is monthly one, multiplied by the square root of 12. But this is a simple method. Actually, it would not give you the result because it is dependent on time, which is exploding. In the sense, if I consider the variance, it will explode. So, if you draw the normal distribution, the overall variance will increase and depend on time. Assume a volatility of Infosys 5% per year and also consider a portfolio with 1 million, 10 lakhs in shares on Infosys. We are interested to find the value of risk for 10 days. Now, the standard deviation of the daily change is given on Infosys if the value of proposition is basically 50,000. Assume that the changes between days are independent, that is very important. We can find out the change in 10 days is given by 158, 114. So, use the same calculation and you can solve your problem. So, with this I will just end the discussion of simple concept of VaR and continue discussing the actual intrinsic properties of VaR and C-VaR in the next class. Thank you.